This is video 5.5.2, solving trigonometric equations in quadratic form. So we're going to continue solving equations for x, but we are, or for the angle measure, but it now has like more complicated form. So this will review your skills with quadratics. Be sure to pause, rewind, and so on if you have struggles with video, and write down your questions and bring them into class. Okay, so let's take a look at this first example. This is example 3 for this section. We have a 2 cosine squared of x plus cosine of x minus 1 equals 0. So we see that this is in quadratic form. I want you to think about the following equation that's comparable to this. 2y squared plus y minus 1 equals 0. This is the same exact equation when y is representing cosine of x. So in Algebra 2 and even in Algebra, you learn how to solve a quadratic equation in this form. You have a couple of options. Remember, there's the quadratic formula. This is only going to work if we have the formula equal to, if we have the equation equal to 0. We also can use factoring to help us solve, because if we can factor this into a product of two things, then one of those two things has to equal 0. And in fact, maybe there's two solutions. Maybe there's two ways to make this equation 0. Because of the 0 product property. Anything times 0 is 0, and the only way to get an answer 0 is to have a number that equals 0 in your product. So I'm going to take a look at 2y squared plus y minus 1, and this is a strategy that many of you will want to use if you get stuck on the cosine of x part. So 2y squared is always going to go in that corner. The only way to get 2y squared is to do 2y and y. Maybe they're both negative, but probably not. Let's see, the other corner I fill in is negative 1 because it has nothing in common with the 2y squared. The only way to get negative 1 is to have a negative 1 and positive 1. And taking a look up at my number of y's, I know they're going to be in these two corners. And so the only way to get them into these two corners is to have the larger one be positive. So I'm going to make this positive 1 and this negative 1. So negative 1, and then positive 2y, negative 1y. And that's how I get my product. So this quadratic equation here is equivalent to the following: 2y minus 1 and y plus 1. Remember, the diamond problem also works here. You wanted the product to be negative 2y squared because that was the product diagonally here. And you wanted the sum to be y. And you guess and check, and you end up getting 2y and negative y. And that's another way to, of course, get it using the diamond problem. So now I'm going to go back to cosines and cosines in this case, and replace every y I see with a cosine of x. So I really have the equation 2 cosine of x minus 1 times cosine of x plus 1. That's equivalent to my original equation, and of course it equals 0. So now I need to figure out when is this 0. So using the 0 product property, I ask the question, when is 2 cosine of x minus 1 equal to 0? Or maybe the other one's 0. When is cosine of x plus 1 equal to 0? These are the two equations I'm going to solve now using the skills I learned from the first video. So I'm going to solve for my variable by getting it alone. I get 2 cosines of x equals 1. I'm going to divide by 2, and I get cosine of x equals 1/2. So I have to figure out when is cosine 1/2, and then that's where my unit circle comes in. So cosine is 1/2, and cosine is x, so cosine is 1/2 here, and cosine is 1/2 here. So my two solutions are pi over 3 and 5 pi over 3. Those two solutions will give me a cosine of 2 cosine of x minus 1 equal to 0. So now let's take a look at this other equation. We're going to solve for cosine of x in the other equation as well. Cosine of x equals negative 1. So then I look on the unit circle. Where is cosine of x? Negative 1. Cosine is x, so it's only here. So at pi. So this will be true when x equals pi. These are my 3 solutions to this quadratic equation. So I have 3 potential solutions. They are pi over 3, 5 pi over 3, and pi. Those are the solutions for this quadratic form of a trigonometric function. So you're going to use your skills from the past along with your understanding of the unit circle and where certain cosines exist. So let's take a look at the next example. Tangent of x plus sine squared of x equals 3 tangent of x. Okay, so this equation, I see it's a quadratic. I see one thing that it's a quadratic. I see that there's tangent and sine, so I'm tempted to think about identities, and you'll see more on that in video 3. But this one can be solved using what we just did. So we're going to take tangent of x sine squared of x equal to 3 tangent of x. What I see is if I subtract 3 tangent of x from both sides, I will have two terms on the left, tangent of x sine squared of x minus 3 tangent of x are my two terms, equals 0. So I see that they have a common factor of tangent of x, so I'm going to factor it out. Tangent x times sine squared of x minus 3. And I'm going to use this zero product property once more to figure out when is that product 0. Because we have a number times another number. And the only way to make 0 is if one of them's 0. So I'm going to ask the question, when is tangent 0? Or perhaps maybe it's the other equation that could be equal to 0. So I'm going to look for these two solutions. So let's see on the unit circle, tangent is the slope, and the slope is 0 along the x-axis. So we have a 0 slope at 2 pi, or I should say 0 degrees if our range is between 0 and 2 pi, and pi. So we have two solutions when x equals pi or 0. Now I'm going to look for the other one. I'm going to solve the other one for sine. So then I square root both sides. It looks like I get sine x equal to square root of 3. Square root of 3, I know that occurs on my unit circle. You see it here. But I don't see just plain old square root of 3. So let me think about this. Sine of x equals square root of 3. When will sine be equal to square root of 3? The answer is never. Sine can never be more than 1, and square root of 3 is about 1.73. Sine can never be greater than 1. So there is no solution to this half of the equation, which means that there is no way to get 0 from this equation, this expression, sine squared minus 3. So the only way to solve this for when these two values will be equal, my original values in my equation, the only way for those two to be equal is if tangent of x equals 0, or when x is pi or 0. So the two solutions are simply these two, because this can never be true. That can never equal square root of 3. Now it's time for you to try it on your own. Okay? Try the following checkpoint. Think about sine x as y, if that helps you. So we have y squared right here, and we have y over there. See if you can use factoring. Maybe you try the quadratic formula, but bring your attempt into class and bring in your questions that you may have about these types of problems. Good luck, and we'll see you in class tomorrow.